Mobile NAC, which is a concept, there's two types of NAC, I'll show you. Mobile NAC as a concept would be able to protect them against that. Another thing that would protect them was zero-day protection, where it's not looking at what something looks like, it looks at what something's done. Hey, you know what? You're visiting Melissa's webpage and it's downloading something and is modifying the registry and doing all this. I don't know what it's called, but I'm not going to allow it to happen. That would also stop it. So we'll dig a little bit deeper on that now. You know, when I talk to companies and I say, well, what are you looking to do to protect your corporate devices? And they say, well, you know, we're looking at Cisco NAC and Microsoft NAP. I say, well, that's great, but not really designed to protect your mobile devices. And here's why. And nothing against Cisco and Microsoft, by the way. But if you look at their own product descriptions on what they're supposed to do, they protect the corporate LAN from devices that are bad. You look at any LAN-based NAC solution, that's exactly what they're going to say in their own words. We're going to protect the corporate LAN against devices whose security posture are deficient from coming onto the LAN. And that's what this diagram shows right here. So basically what happens is you have the laptop over here who connects to the internet. They launch their VPN client, and as they're coming onto the network, they're assessed. Do you have all these patches? Your antivirus running up to date? You got that personal firewall running? You got your encryption application installed? Whatever the menu of items that it wants to look. If all those things are true, then I'm going to let you in. If those things aren't true, I'm going to put you on a separate network, and I'm going to hopefully fix you. Okay? So what it's designed to do is to protect this area right here from this device.
Touchscreen's not working.
Touchscreen's not working?
Well, yeah, it may be going to the recording, but we're not seeing it here. Sorry.
I'll be more illustrative as I talk then. Let me take it out of here. Let me get rid of the... So basically, that area in the red, where you don't have that control, where the person's sitting in a Wi-Fi hotspot, that's called the mobile blind spot. You can see just by the nature of this solution that if your assessment, quarantining, and remediation point is when you're coming back to the LAN, what does it do to you when you don't come back to the LAN? And the answer is absolutely nothing. So you look at that whole red area there. There's no protection being afforded it by that LAN-based NAC solution. It's not even talking to it. Somebody sitting at home, they plug in their laptop, there's nothing going on. It's not talking to those servers. They're not even in play. And I can tell you, as a trend, that more and more often people are actually connecting less. Why? There's less of a need to. A lot of applications are becoming webified. People are spending more and more time just connected to the internet and not actually VPNing back to the corporate network. Okay? Now compare that assessment that happens as they connect to this slide here on mobile NAC, the concept of mobile NAC. Well, what if instead of assessing them as they came into the VPN, what if as soon as they started their machine there was an assessment? Got all these things in place? Yes or no? You're compliant or you're not? If you are compliant, go ahead and connect to that hotspot at T-Mobile. Go ahead and connect to that home network. But you know what? If you're not compliant, before you even try to connect, let's do a couple of different things here. One is how about automatically fix the problem, and the second is quarantine and limit their functionality. So for example, let's say they got infected with a piece of malware that shut off their antivirus software. Why not just restart their antivirus software for them? That makes sense, right? This is something that mobile NAC is able to do. If something's deficient, automatically fix it. Hey, you don't have that Microsoft patch that came out that makes you vulnerable to visiting a web page and getting hacked? Let me get you that patch as your mobile. Right? Fixing the problem automatically. Not prompting an end user, hey, Mr. End User, go to this website and download this. That's crazy. All this should happen in the background. So in fixing the problem, it might take time to do that, and it might not be able to fix. How about quarantining and limiting their functionality? You know what? Your antivirus software isn't working. How about you can't use Word until then? That makes sense, right? Because that could infect you. How about if you're non-compliant, you can't use your VPN client, and you can't come into the network? Then how about if you're missing an Internet Explorer patch, you're not allowed to use Internet Explorer until you get that patch? That all makes sense. But then also look at it from a layer 3 perspective. If you're non-compliant, your security posture is deficient, how about you can't go everywhere in the world on the internet? How about the only places you can go to are servers that are going to fix you? And that's it. That makes a whole lot of sense. So the difference between, if you look at it, the difference between LAN-based NAC, which had that big mobile blind spot there on the left that was red, and mobile NAC is that mobile NAC protects the endpoint. You can see that assessment, quarantining, and remediation point is on the laptop. It's software sitting on the laptop enforcing all that stuff. It's not a piece of hardware that's sitting on a firewall on the other side of the LAN that's only accessible when you're on the LAN. So it's truly designed to protect the mobile laptop as it's mobile. Big difference between protecting the corporate LAN. Does that make sense to everybody? Okay, that's a pretty important concept that's out there. So again, this is a conceptual thing. So, you know, it's funny, we come across all these different NAC and NAP solutions that come across the pipe. Say, wow, well, how does that one work? What does that do? What are the components of that? You know what? Ultimately, it doesn't matter. Is it going to protect your mobile from a mobility standpoint? Are you going to protect the mobile device with it or not? If it's sitting on, it's a piece of hardware behind the firewall, you're not going to. Okay? So that's the knack part of it. But you know, that vector that we were talking about also was lost and stolen laptops, right? And I'm sure you guys, you can look at all the different statistics you have about it. But it's actually kind of funny because people ask me to say, well, that's fine. If if my laptop is lost, you know, I got a really hard Windows password on there. So somebody would have to guess this 16-character Windows password on there to be able to get access to my data. It's like, really? That's actually not true. There's a couple applications on there. I have Helix mentioned here. On this USB drive right here, if there was a laptop that didn't have encryption on it and it was sitting here, I can boot to it in probably 2 minutes. I can access any file that I wanted to on there. I can copy it over to here. I can mess with it. I can create usernames on an account. I can do anything I wanted to a laptop that was sitting here because I have this operating system that can boot off this. This is Backtrack, by the way. If you go to remoteexploit.org, you can download it. It's real easy. You can run it off a USB, and then you can log into any machine. Not even log into any machine. Access the data on any machine via this operating system. It's pretty cool stuff. So the fact of the matter is this: it doesn't matter how strong a Windows password is to protect your laptop if the Windows password isn't used to access the laptop. If you're using a different operating system. I love this slide here. This is one of my favorite slides. I was doing an interview with John Galan of Network World. He's their head guy there. And I said, you know what, I actually use this slide in some of my presentations. He says, oh, that's great. Thanks, Dan. Well, this is from 2006. And basically what it said in 2006 is if you as a company don't have encryption, you're a turkey. It was around Thanksgiving time. That's a turkey kind of connotation. And I loved it. And you know what? It made sense. Because how many laptops need to get lost or stolen? How many customer records? How many patient records need to get stolen before companies say, I'm going to implement encryption? Right? How many does it need to happen? And this is from 2006. It's 2008. So what are you if you don't have it now? Right? Something worse than a turkey, I suppose. And it's funny because some companies I talk to say, you know what, I'm going to do encryption, but I'm going to tie it to my operating system, right? Vista just came out with its BitLocker. I'm going to go ahead and I'm going to do that. And you know what? That might be a fine strategy for a lot of companies. I've talked to one company of all the companies I talked to throughout the year. I've talked to one company that's actually going to have Vista deployed this year. This isn't a knock against Microsoft. It's not a knock against their technology. But if somebody's tying their encryption solution to rolling out Vista, most companies I'm talking to are waiting 2 or 3 years to do that. 2 or 3 more years without encryption on there because we're going to tie it into the operating system. That's not a risk I would take. And then another thing companies talk about is EFS. You guys heard of that encrypted file system from Microsoft? They say, well, we use EFS. Well, that's great. Problem with EFS is it's going to be bypassed in about 5 minutes. Okay? And how is that done? Well, here's the steps right there. If you look at the blue box, you boot to a laptop using a tool called ChangeNT Password, which, by the way, is on this USB drive, too. So I just kind of slapped this in. I run ChangeNT Password. I change the administrator password. I log in as the administrator. Then I change the password of the user account to whom I want to access the machine. I log in as that user, and the data is decrypted. That's not hard. That's about 5 minutes worth of work. That's why it's not an enterprise tool. If I was my grandma, which I shouldn't use grandma, both my grandmas are dead, but if I was my mom, would I use EFS? Probably instead of nothing. Why not? You know, it's like using WEP. It can be cracked, but what the heck? At least close the door a little bit. If I was an enterprise, no way would I use this. Think about an enterprise with patient data on there. Are you kidding me? It can be bypassed in 5 minutes. So that's just something to think about. Another thing is USB ports in general. I remember reading, it was in newsletters, it was on blogs and all this other stuff about companies saying, you know what, USB drives, or USB ports rather, they're real susceptible. That's a big problem for us as enterprises because people can connect different devices in there and it's just kind of a nightmare. So we super glued them so people couldn't use them. That honestly, that was actually true what happened. It was like, really? Well, how do people print? Because you take your machine home, you maybe have wireless printing, but you connect your USB cable. How are you supposed to print while you're at home? So it's kind of a funny thing. I actually had the pleasure of speaking with a security guy at one of the largest healthcare companies in the world. He said, you know what, we have an HR policy that if you connect a USB device to one of our company's laptops, you're fired. Think about it. They're a big healthcare company. I would imagine a number of you actually have your insurance through them. They said, if you connect a USB drive to here, you're fired. End of story. Well, the security guy kind of knew better. He's like, people do that all the time. They're not trying